Today we're going to start talking about what are called compound inequalities. Now the word compound means that we're taking multiple things and putting them together. I've got an example of some compound situations here where we have to consider multiple requirements in these sentences. There are two words that are absolutely key for this, which we'll talk about, and then we'll move on to our inequalities. So our first sentence, I need someone who is in 9th grade and a basketball player. The most important word in this sentence right here is and. And means that both of these requirements have to be satisfied. That person has to be in 9th grade and they have to be a basketball player. If either one of those isn't true, we can't pick that person. This sentence, on the other hand, I need someone who is in 9th grade or a basketball player. The word or changes the situation. Or means that if they're not in 9th grade, we can pick them. Or if they're a basketball player, we can pick them. They don't have to be both in 9th grade and a basketball player. So the difference between and or, and means that both have to be true, or if there are more requirements, they all have to be true. Or means that either one could be true and we accept that. So those two situations are key. Let's take a look at these two graphs. They kind of illustrate the difference between the two. You'll notice that this inequality has two separate parts to the graph, one going left over there and one going to the right over here. This is a situation where we need the word or. We have this inequality, which would be x is less than or equal to -1. This inequality would be x is greater than 2. And you'll notice the shading indicates that our solutions are found in both places. So we have solutions here. We also have solutions there. And the word or connects them. So if you see something like this, x is less than or equal to -1, that would be all of these numbers. Or another possible solution would be x is greater than 2, would be all of these numbers. And it doesn't have to fit both of them. It has to fit one or the other. If it does fit both of them, that's okay too. This one is also two separate inequalities. It's a little harder to see. We've got one that starts at 3 and goes to the left, and a second one that starts at -4 and goes off to the right. And you'll notice that this area over here is not part of our full solution right here. We only keep numbers between -4 and 3. That means these numbers over here have been erased. And these numbers over here have been erased. And we only keep the numbers where they overlap, where both of them fit. So this is a situation that requires and. Okay, let's write down our two inequalities. This would be x is less than 3. This one would be x is greater than -4, and our solutions that we're keeping have to fit both of these, which is the word and. And means that we throw out something that doesn't fit one or the other. So let's take a look at a few different examples, and we will see some situations where we have to create a graph, we have to interpret the word or and the word and. Okay, I'm going to draw both of them and then decide what to keep. And that's kind of a typical way that I see, make sure that I get everything that I need. So p is greater than 2. That would be an open circle at 2 and going to the right. P is less than or equal to -2. That would be a closed circle at -2. And we're going to the left. The word is or. So or means it's a solution if it fits this one. It is also a solution if it fits this one, and we don't need to fit both of them. So we're going to keep this, we're going to keep that, we're going to keep the entire thing. So I'm going to shade to the left right here on my graph, and I'm going to shade off to the right over here on my graph. And we're going to keep everything. Let's take a look at the next one. I'm going to draw these two again. X is less than 7, so I'm going to put an open circle here at 7 and go to the left. X is greater than 4, so an open circle here and go to the right. The word and means it has to fit both of them. So you'll notice in this area over here, it doesn't fit x is greater than 4. So I'm going to erase this area. And over in this area, it doesn't fit x is less than 7. So I'm going to erase that area. And I only keep where it works for both of them. Well, that's in between the numbers 4 and 7. And over here at 4, we have an open circle. And over here at 7, we have an open circle. That means that 4 and 7 themselves do not work. All right, you might also see this inequality written this way. 4 is less than x is less than 7. So we're going to see this combined in this way. If you ever see two inequalities combined in a single statement, this is always an and statement. All right, so we'll see these in the future. Let's take a look at this last one. X is greater than 6 and x is greater than or equal to 2. So here we go. Open circle at 6 going to the right. Closed circle at 2 also going to the right. Now you'll notice these are going the same direction as opposed to the last example where they went opposite directions. But we still take a look at the word and. We're going to keep where they both work. Okay, here is an area where one of them does not work while the other one does. So I'm going to throw this area out. That does not work because it doesn't work for x is greater than 6. This is where they work for both. So we're going to start at 6 and we're going to go all the way to the right, and it goes forever to the right. So you'll notice that this situation looks a little bit different than the last one. We just have to take a look at the two graphs, put both of them on there, and then analyze the word and or, and make sure you keep everything that is a solution and you don't keep the parts that are not. There are infinitely many examples of this, variations on it, so you have to be able to just stop and analyze those words. Thank you.